Oftentimes when doing stoichiometry problems, we don't work between just moles and moles. There's grams incorporated into it. And it makes sense because when we're in lab, what do we measure in? We usually measure our substances in grams, especially if we're working with solids. So it's not uncommon for us to see stoichiometry problems that involve both grams and moles. So in this lesson, we're going to look at problems where we're going from moles to grams or from grams to moles. Now I have the image of the steps from your book. And so remember, in yellow, over on this side, these are the units that we'll be given in the problem. So it will be one of these three things. And then over on the peach kind of side, colored side, these are the units that we'll ask to find. And the number of steps you do in the example here in the path or the map, there's 3 total steps. That you will use 3 steps only when you go from the farthest, from grams to grams, from one end to the other. But sometimes we can go 1 step. We learned you only use the mole ratio when you go from moles to moles in the problem, so that's only 1 step. And in this problem, you'll see these problems when you're going from moles to grams or grams to moles, you'll be doing 2 steps. So let's investigate. So just like we have had before, in stoichiometry problems, you need a balanced chemical equation. So I've been using this kind of as my jumping off point. So here's my balanced chemical equation. And remember, the main part of this is that we need the mole ratio from this equation. Now remember, at this point we're introducing grams, but the ratio from the balanced chemical equation cannot be grams. It's not grams. That's incorrect. It can only be, for what we're working with, moles. Okay? So we read the problem carefully, and it says, how many grams of ammonia? So there's 2 things I get from that question. I'm looking for grams. So I see over here, this is what I'm going to be trying to find. Okay, so that's my unit, and I'm going to be working with the ammonia. So this right here is what I'm trying to find. Okay, in grams. So those are the 2 things. And then are produced from 2 moles of hydrogen. So here again, now I get two bits of information. I see that the units that I was given are moles. And what I'm looking for in my equation is going to be the hydrogen. So that's right here. So looking at my plan, if I'm given moles, I can jump right in and use the mole ratio. So the first thing I'm going to do is use the mole ratio, but that would only get me to moles of B. So then if I want to go from moles of B, but I need to get to grams of B, it's going to require another step. In this case, this would be step 1, and this is going to be step 2. But to go from moles to grams, then I use the molar mass. So this problem is going to take 2 steps. The first step is the mole ratio, because I was given moles, so I can use the mole ratio right away. And then the second step, to go from moles to grams, I need to use the molar mass. So let's see, moles of A. So I'm given 2.0 moles of hydrogen, and I want to find ammonia, so I can use the mole ratio right away. I put what's on the bottom, it's what's given, so I have a 3 in front of the hydrogen, and then on the top will be the 2, because that's in front of it. So the first step is simply the mole ratio. So that's 2 times 2 divided by 3. So I get 1.3333 moles. and this is ammonia. Now, it's actually kind of important not to round after this first step, because this is not our answer. This is an intermediate step. And for some of you, you may like to solve this in a continuous manner. On some of the videos, I have it in a continuous manner. And at the end of this video, I have two more problems after this one. The last one I'll set up as a continuous problem. And you can practice both ways, or maybe one way is just easier for you. It doesn't matter. You choose the way that's best. So I did my first step. So now following along, I went from here to here. So now I'm at moles of B. Now, to get moles of ammonia, the question asks for grams. So I'm going to have to convert grams into moles, which is not a new thing to us. To go from grams into moles, I'm going to use the molar mass. Okay, so now I have to calculate it. So to calculate the molar mass, I'm going to look up in the periodic table. So it's 1 nitrogen, and nitrogen is 14.01 grams per mole. And then hydrogen is 1.008, but there's 3 of them. So that is 3.024. And then I have to add the 14.01 plus the 3.024. And I will get my molar mass. So this is 0.034, and it's molar mass, so it's that many grams per mole. Okay, so now let's think about it. Remember, this is not from this chapter. Since I'm given moles, I want the 1 mole on the bottom, and the 17.03 should be 34 on the top. And so I will take 17.034 times 1.33333, and I get 22.71, and it keeps going. Well, looking back, that's grams of ammonia, but looking back, I was given just 2 significant figures, so I'm going to say 23 grams of ammonia. So that if you reread the question, it says how many grams of ammonia are produced from 2 moles of hydrogen. So if you start with 2 moles of hydrogen, then you would produce 23 grams of ammonia. And because we're going from moles into grams, this problem required 2 steps. The ratio first, because we were given moles, and then the grams. So let's try another one. So here's another a problem, and looking, here's the balanced chemical equation right there. So we're given that, and then we read the problem. It says how many grams of mercury. So here's the mercury, and this is what I have to find. And notice that I'm working with grams. Are produced along with, and then I have 9.5 moles of calcium sulfate. So here's my calcium sulfate, and this is what I'm given, and I'm given it in moles. So remembering our steps from the first part, it kind of goes like this. It goes grams to moles. That's what you're given. And then from there, if you wanted to find it, I'm trying to change colors, it goes from moles to grams. And so when we're given, so to go from grams to moles, this is the molar mass. To go from moles to moles, this is the ratio. And to go from moles to grams, this is the molar mass. And this is kind of a sketch. And I really think you should kind of get to this point where you take that little map and you can kind of sketch out a plan. So in the blue is what's given, and I'm given moles. And then in the purple here, that's what we're looking for, and I'm looking for grams. So if you can see, I can tell I'm going to have two steps. I have to use the ratio first, and then I'll use the molar mass. So I'm going to go moles to moles first, and then moles to grams. So I write down what I'm given, 9.75 moles. And I can use the mole ratio. Since I have moles, I can use the mole ratio to change into moles of mercury. So there's a 1 in front of the calcium sulfate. So I would put the 1 mole of the, you always put what's given on the bottom. If we were in class, I'd ask you why, and hopefully you'd say that's because you want them to cancel. And then what you're looking for, what you're trying to find, is mercury, and that has a 4 in front of it. So my moles of calcium sulfate cancel. And so on the first step, what I can do to go from moles to moles, I'd say 9.75 times 4. And remember, at this point, you don't want to round, but this ends up being 39. So that's 39 moles of mercury. Now, that's not my answer. I just went the first step. I used the ratio, so now I have moles of mercury. But if you come back up to the problem, I have to go to grams. And from a previous chapter, we know to go from moles to grams, we need the molar mass. So the molar mass of mercury, I don't have to add up any, is 200.6 grams per mole. So the second step would be to say 39 moles of mercury, and then I'm going to put the moles on the bottom and the 200.6 grams on the top. These are for mercury, so that cancels. And I get 39 times 200.6. And now I get 7,823, 0.4 grams of mercury. And if I look back, I started with 3 significant figures, so I'm going to say 7,820 grams of mercury. You could also write this in exponential notation if you wanted. So let's try one more problem, and if you'd like to see more, if you go, there is another section under class lessons that has more problems worked. But you can pause it now and try to solve this problem, and then I'm going to go ahead and solve it. So I've started with the balanced equation. And then I'm going to read my problem. And it says how many moles of calcium oxide. So this is what I'm looking for. So I find the calcium oxide, and this is what I want to find. And I also note that that's in moles. And then are required to react with 97.25 grams of the mercury sulfide. And so this right here is what I'm given. And I'm given this in grams. So let's just review the general process that we go through to get these answers. You're either given grams or you're given moles. So the blue I'm using is what you're given. And then you kind of cross over into what you're trying to find, and you're either going to try to find moles, and the pink are what we're trying to find, or you're going to try to find grams. Now in this process, it's always kind of similar. To go from grams to moles, we need the molar mass. To go from moles to moles, we need the ratio. And to go from grams to moles, we need moles to grams, we need the molar mass. So there's a total possible of 3 steps. But you have to look at what you're given to kind of know the steps you want. So I'm looking back at what I'm given. I'm given grams. So here's where I'm going to start in my process. And I'm asked to find moles. So here's where I need to finish. So in this problem, this part is not relevant to it. So I'm going to have 2 steps. I have to convert grams to moles because remember, you can only use the ratio when you're in moles. And then I'm going to go from moles to moles by using the ratio. So I'm going to start by the first thing I need to do to go from grams to moles is figure out the molar mass. So let's see, for mercury, I have grams of mercury sulfide. So mercury is 200.6 and sulfur is 32.07. So if I add these two things together, 200.6 plus 32.07, and I get 232.67 grams per mole. So I write down what I was given right here. 97.25 grams of mercury sulfide. And the first step is going to be to change that into moles. So I need to divide by the molar mass because I'm going to put the grams on the bottom and the moles on the top. Now, I'm going to set this, I want to set this up like a continuous problem. But I will tell you, if you're doing this step by step, you'd say 97.25 divided by 232.67, and your answer right now would be 0.41797 moles. That's kind of what you would have right now. Now, my personal preference is to do these as continuous problems, so I would do step 1, and then instead of solving for an answer, now I would see, okay, now I need to multiply by the ratio, and I would just set it up here now. So I know I've canceled out my grams of mercury sulfide, and I have moles of mercury sulfide now. So then I want what's given will go on the bottom, so that's a 4. In front of the mercury sulfide, and I'm trying to find moles of calcium oxide. That also has a 4, so it's really a 1-to-1. That cancels out the mercury sulfide, and now I would have my answer. So I would take my 0.4179, multiply by 4 or divide by 4, which is the same as multiplying by 1, and you should get 0.41797, moles of calcium oxide. Now looking back at significant figures, I only had 4, so let's put it 0.41. Oh, let's see, so 7's going to round that up. 80 moles of calcium oxide. Oh, I'm getting too close to the edge. Would be my final answer. Now, I know some of you think, oh no, I don't like continuous problems. You don't have to do it that way. You can continue to divide it. When you have 2 steps, you can write down 2 individual steps. Some of you may like to do it continuous, and honestly, as long as you're showing your work, whatever is easiest for you to work through the problem, that is perfectly fine with me.